lot of students were having issues with stoichiometry today. They came in for help, and I want to make sure that everyone gets the right information. So this is a brief review on stoichiometry. If you don't remember it, now is the time to perk up your ears. So I teach this in a different way than Miss Warden teaches it, than Mr. Vogt teaches it. So if this makes sense to you, you can follow this method, and if you were taught a different way, you can follow the method that you were taught. So stoichiometry, when I say stoichiometry, it's just a way of measuring quantities in a given reaction. So we use a mole ratio in order to do that. You usually start with one thing and you're looking for another. And so this is the stoichiometry roadmap that I use with my general chemistry students. So the first thing I do is label what conversions need to be used in this roadmap in order to get from mass to moles, moles to mass, etc. So if you're starting in a mass and you need to get to moles, we should all know this by now, but you put molar mass on the bottom. And 1 mole on the top. To get from particles to moles, we divide by Avogadro's number. So 6.022 times 10 to the 23rd is on top, and 1 mole, is on the bottom, and 1 mole is on top. And then if you're starting in volume, which will be liters, you have to divide by 22.4 liters in 1 mole. So these are the conversions you would use if you're starting in mass, particles, or moles. By the way, particles can either be atoms, or it could be molecules, or it can be a formula unit. Formula units are just the same as molecules, but for ionic substances. So don't get too confused if you see formula units. It just means particles, and you can use Avogadro's number. This middle conversion here, you're going to want to use the mole ratio that you get from your reaction. You're going to put the ratio of what you want over what you have or what you started with. But these numbers always come from the coefficients in the formula. And we're going to go through a few examples of this, so if it doesn't make sense right now, it will in a second. Lastly, if you want to go from moles to mass, now we put 1 mole on the bottom, molar mass on top, in grams. Moles to particles, we put 1 mole on the bottom, and then Avogadro's number on top. And then moles to volume, 1 mole on the bottom, and 22.4 liters on top. So this is the essential basic roadmap that can help you solve any stoichiometry problem that comes your way. So to break down a few examples of how this is used, I'll let you guys see a couple examples. So let's see, the first question I have looks like this. How many grams of Li3N are required to form 0.78 grams of LiOH? So this is the question. Here's the formula that we use for the question. Looking at our roadmap along with this question, we want to identify what we have versus what we're looking for. So the question, let's see, how many grams of Li3N? That's what we're looking for, so that's going to be our B. So I'm going to underline that, grams of Li3N. I'm going to label that my B. This is what I want. Okay? What I'm starting with is my given. Okay, it's my grams of LiOH, and I'm going to label that my A. Okay? What I'm also going to do is label the coefficient that goes along with each of these things. So for the A, it's LiOH, so I underline the 3, and what I want is my B, Li3N, and so I underline that imaginary 1 that is not technically written. Okay? So now I've got this set up, I can identify where I'm starting. So for this problem, I'm starting in grams, okay? Grams of LiOH, so that's mass. So I'm starting mass, and I'm looking for grams of my product, so I'm going to the B in mass. So this tells me I'm going to do 1, 2, 3 conversions. Each line that you go through is a different conversion, okay? So the first conversion, okay, so I'm going to start with what I'm given. That's always what you're going to start with, is what you're given. So I'm going to start with my 0.78 grams of LiOH. According to my roadmap, I need to divide by molar mass, so I'm going to put 1 mole of LiOH on top, and then the molar mass of LiOH is 23.95 grams. Okay, so that's my first conversion that I have to do. Now, on to my next conversion. I have to go from moles of LiOH to my moles of Li3N. I'm going to use the mole ratio in order to do that. So, according to the formula, the moles of LiOH are 3. So I'm going to put 3 moles of LiOH on the bottom here. Again, that's because I have this. I'm starting with that. That's my given. So I put that on the bottom. Then what I'm looking for goes on top. So what I'm looking for, according to the formula, there's 1 mole of Li3N. So 1 mole Li3N goes on top. So that was my mole ratio step. That was this step right here in the roadmap. The last step for me, remember we said we're going to start at massive A and end at massive B. So I did this conversion, and now I'm ending on this last conversion here. I need to put molar mass on top and 1 mole on the bottom. So I'm going to have 1 mole Li3N on the bottom, and the molar mass for that is 34.83 grams. Alright, and then in my calculator, 0.78 divided by 23.59 divided by 3 times 23.83, and that will get me my answer. So when I get that out with proper sig figs, my answer is 0.38 grams of Li3N. Okay? I want to stress, guys, I know I set this up correctly because I can cross out units. So this was LiOH. So this is grams of LiOH and grams of LiOH, moles of LiOH, moles of LiOH, moles of Li3N, moles of Li3N, left in grams of Li3N, which is what I'm looking for, so I know I did it correctly. Okay? So that was a mass to mass example. You can do it a lot shorter though, if you, depending on the question, there's a lot of different versions of this. So I'll give you guys another example for this one, number 2. We have how many moles of H2 are required to produce 17 moles of Li3, or I'm sorry, of NH3. So in this case, what we are starting with, what our given is moles of NH3, so I'm going to label that my A. What I want is moles of H2, so I'm going to label that my B. And now I can pick where I'm starting and ending here on my roadmap. So according to this, I'm in moles of A, so I'm starting there. And I want moles of B, so I'm ending here. So all I have to do is one conversion and then I'll be done. So that's what I'm going to start with next. So you always start these problems with what you're given. So I have 17 moles of NH3. Now comes the mole ratio step. So what it's want over have. So what I'm looking for is H2, and so what I have is NH3, so I'm going to put my 2 moles, remember I have 2, you have to use the coefficient from the formula, so 2 moles of NH3 on top, and then I want H2, so I'm going to use the coefficient in front of H2 on the top there. Now I can double check that I've got everything set up correctly. I have moles of NH3 and moles of NH3 canceling out, leaving me in moles of H2, which tells me I did this correctly. And so doing that math out, I'll end up getting 25.5 moles of H2. Okay, notice how I'm boxing my answers, crossing out my units, labeling all of my conversions. This is the exact setup that I want to see on your papers. Okay, we'll do one more example, and hopefully this will be enough for you guys to kind of get a good grasp on it, and if not, I'm always available after school or during lunch for sure. Okay, so what volume of NH3 is produced when 2.4 grams of N2 react with excess H2? This word excess H2, whenever you guys see that, that just means that there's extra lying around, like it's not going to stop the reaction at all. It basically means don't worry about this running out, the reaction will go to completion. So it's basically you can ignore it. Okay, so alright, so in this case we have to identify what we're given as our A. So it looks like we have this as our given, grams of N2. We are looking for volume of NH3, so that's our B. I'll underline my coefficients that I'm going to use as well. So NH3 was here, N2 is here with an imaginary 1. And now I can start the problem. So let's identify where we're starting. I'm starting in mass of A, and it's asking for volume of NH3, so that's all the way down here. So I'm going to have to go mass to moles, and then moles to moles, and then moles to volume. So I have 3 different conversions I'm going to have to do. Alright, so let's go ahead and do it. So starting with what I'm given, 2.40 grams of N2. My first conversion, according to my roadmap, I have 1 mole of N2 on top. And on the bottom, I have the molar mass is 28.02 grams. So that was this conversion here. The next conversion is my mole ratio step. I put want over have. So let's see, I have N2, that's 1 mole. N2, again, these numbers have to come from the equation itself. And then what I want is up here, I have 2 moles of NH3 on top. So that was my mole ratio step. And then my last step, I have to get down here to volume. So my conversion tells me I have 22.4 liters over 1 mole. So 22.4 liters of NH3 for 1 mole of NH3. So double checking that I have this set up correctly, grams of N2 cross out, moles of N2 cross out, moles of NH3 cross out, and I'm left in liters of NH3, which is what I want. So I know I've set this up correctly. Now in my calculator, 2.4 divided by 28.02 times 2 times 22.4, and that will give me my answer. So once I do that, I'll end up getting 3.84 liters of NH3. And we're done. Okay, so I hope this helps you understand stoichiometry a little bit better. Again, if you have problems or questions, let me know. I'll be around during lunch or during school or advisory. Come and see me.